All right, so we're going to do a second day of learning about the intermediate value theorem here. Um, we learned on our last lesson right at the end that we have to prove, we have to state two conditions, and then we can state the conclusion, which we're just going to say IVT applies. The full conclusion is here. Then there exists a number C between A and B for which f of C is equal to K. All right, so we drew out the graph last time. So the conditions that we have to state are, number one, f of x is continuous on the closed interval, and number three here, that k is between f of a and f of b. Okay, and f of a and f of b, we're just going to find those values, and number two is they can't be equal to each other, but that's going to automatically kind of happen when we show that k is between them. So we don't have to worry about number two being a specific thing we have to find. All right, so it gives you in other words, I had us draw a graph last time. Hopefully you have that in your notes already. So I'm going to go ahead and move on to our first example. All right, so we're going to determine if the intermediate value theorem holds for a given value of k. If it does hold, we're going to find the c value for which f of c is equal to k. If the theorem doesn't hold, we will say why, and then we'll draw a sketch. Okay, so for the theorem to hold, we need to first say that f of x is continuous. Now, this function has a discontinuity. The discontinuity is located at x equals 2, because that is where a vertical asymptote is located on this graph, because that's where the denominator is equal to 0. Okay, but remember, the function only has to have continuity on the interval given. So look at the interval over here. The interval goes from 2.5 to 7. So 2 is not inside the interval. So we can say that f of x is continuous. If you just stop right there, f of x is continuous, you have said something wrong. Okay, so this one's very important that you say on the interval from 2.5 to 7. Okay, I just want you to be in that habit of always stating the interval when you say continuity, because there are times like this one where it would be wrong to not state it on the interval. All right, number two, we need to find our f of a and f of b. So f of a is f of 2.5. So that's equal to 1 over 2.5 minus 2. So that's 1 over 1/2. 1 over a number is the reciprocal of that number. So that's equal to 2. F of 7 is 1 over 7 minus 2, which is 1/5. All right, and then we need to show that k, which they told us is 1/4, is between these two numbers. Okay, 1/4 is bigger than 1/5. So it's bigger than 1/5, and 1/4 is smaller than 2. So we can say that f of 7, which is equal to 1/5, is less than or equal to 1/4, which is less than or equal to 2, which equals f of 2.5. All right, we have done everything we need to do for the conditions. So we finished by saying, therefore, IVT applies. All right, part B, I should say. So this is all part A. So part B, we are now going to find the C value for which f of C is equal to K. Okay, so f of C is the function with a C plugged into it. So that's 1 over C minus 2 is equal to K, which is 1/4. Since both the numerators are 1, we just set the denominators equal to each other. C minus 2 is equal to 4, which means that C is equal to 6. You could also cross multiply because we have a proportion, and you get C minus 2 is equal to 4. Same thing. All right, and then letter C is to draw a sketch. Okay, so we only need the first quadrant because both of our y values are positive and our x values are all positive. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2. All right, so and then we go up to +2, so I'll do 1, 2 there. Okay, f of 2.5 was 2, so that's right there. F of 7 was 1/5, so kind of pretty close to the x-axis down here. So our curve's going to go down like that, something like that. Okay, and then k equals 1/4 is a little bit above here, right there, like that. Not the best drawing, but we get the idea. And what you're trying to see here is that, this is f of x, is that they intersect right here. And I tried to draw it to where you can see that that intersection is happening where x is equal to 6. Okay, if we used a calculator or a graphing utility, we would be able to see that it does intersect exactly at the point 6 comma 1/4. That's what this point is, 6 comma 1/4 right there. All right, let's try another one. So this one, we have a quadratic equation. Okay, so on this one, quadratic equations are always continuous. So we just say f of x is continuous, and you can stop right there. That is true. F of x is continuous because it is continuous everywhere. But I would like you to say on 0 to 5, just to get in the habit of always saying on the interval. All right, number 2, we need to find our y values, f of 0. Okay, 0, 0, minus 4, so negative 4, and then f of 5. Okay, so that's 5 squared is 25, minus 5 times 3 is 15, minus 4. 25 minus 15 is 10, 10 minus 4 is 6. Okay, and then the k value that they gave us, 1, needs to be between those two numbers, and it is. So f of 0 is equal to negative 4, less than or equal to 1, which is less than or equal to 6, which equals f of 5. All right, therefore, IVT applies. All right, part A, complete. Part B, f of c is equal to k. So f of c is c squared minus 3c minus 4 is equal to 1. All right, and so people always get this wrong because this quadratic they gave us is factorable. We can factor this quadratic equation, but to be able to solve a quadratic equation, it has to be equal to 0. So you have to subtract that 1 over first. C squared minus 3c minus 5 is equal to 0. Now we're in trouble because this is not factorable. There's numbers that multiply to 5 are 1 times 5, and 1 times 5 does not, 1 and 5 do not add up to negative 3 in any way. Any combination, you can do it. All right, so if we can't factor, that means we have to use the quadratic formula. C equals negative b. B is negative 3, so that turns it positive 3, plus or minus the square root of b squared minus 4ac. A is 1, c is negative 5. That's all inside the square root, and that's all divided by 2 times a. All right, let's simplify. C is equal to 3 plus or minus the square root of 9 plus 20. So 29 all over 2. Okay, so 29 is a prime number. We can't simplify this, so this is our answer, but there are two answers, really. There's 3 plus the square root of 29 over 2, and there's 3 minus the square root of 29 over 2. So you want to think about, do both of those answers work? Okay, remember that your answer has to be on the given interval. So our answer has to be between 0 and 5. Okay, we didn't really run into that problem last time because we only got the single answer, and 6 was in between 2.5 and 7. Okay, but here, one of these doesn't work. Okay, so I don't know what the square root of 29 is off the top of my head, but I know what the square root of 25 is. Square root of 25 is 5. So if I just pretend this is 5, that would be 3 minus 5, which would be negative 2, divided by 2, which would be negative 1. And that would not be in our interval. Okay, so the 3 minus version does not work. So the one we want is c equals 3 plus the square root of 29 over 2. Again, you can think of this like 3 plus 5 is 8, divided by 2 is 4, and 4 is inside our interval. All right, part C wants us to graph. All right, let's see here. So I think we'll need a full graph this time. Okay, I'm going to factor my original function, x plus 1 times x minus 4. That gives me zeros. So I get a 0 at negative 1 and a 0 at positive 4. 0, 0. I have 2 points here. F of 0 is negative 4. 1, 2, 3, 4. And f of 5 is 6. 1, 2, 3, 4, 5, 6. All right, and then I'm just going to plug in some numbers like 1, 2, and 3. just to see what the rest of this graph looks like over here. Okay, so if I plug in 1, I get 1 minus 3. Here, I'll write it down. 1 minus 3 minus 4. Negative 2 minus 4 is negative 6. So 1 negative 6. All right, if I plug in 2, I get 4 minus 6 minus 4. So negative 6 again. If I plug in 3, I get 9 minus 9 minus 4. So negative 4 again. So that's kind of telling me I'm like right down at the end here. I don't need to graph anything to the left of 0 because, again, my interval is 0 to 5. So I'm going to start here. It goes down. It's going to go off my screen a bit and then back up through there, through there. There's my parabola. Okay, I'm going to graph k equals 1. So that's this horizontal line right here, like that. K equals 1. This graph is f of x. And so what we're looking at is this intersection point right there. All right, and I said it's a little bit bigger than 4, right? Because 3 plus 5 would be 8, divided by 2 is 4. 4 is right here, but the square root of 29 is really a little bit bigger than 5, right? Because square root of 25 is 5. So it's really 3, it's like 8 point something on top, divided by 2 is going to be 4 point something. So there's our C value right there, which we're saying is 3 plus the square root of 29 all over 2 right there. All right, so you have a worksheet for your homework, and I'll see you for the next lesson.